about solutions. Add-on desires.
Dear students, let us start the very interesting and important topic of physics, which is kinematics, right? So, what is kinematics? What the kinematics deals, and every detail we are going to learn in detail, one after the other, right? Yeah, students, as usual, let us start with the synopsis session. So, what is mechanics? So, mechanics majorly deals with motion of objects. That's all. Motion of objects in our daily life. If you see the objects that are in motion in your daily life, there may be a bike which is moving on the road, there may be a bird which is flying in the air, there may be a person who is walking on the road. All these are the general examples for uh, bodies in motion. So children are playing cricket, so they are throwing some ball, the motion of ball. So obviously all these are the objects that are in motion that we observe in our daily life, right? So here the branch of physics which deals with the motion of objects, in our daily life is called generally mechanics. So students, mechanics is broadly classified into three categories. Mechanics is broadly classified into three categories, that is like kinematics. Number one, kinematics. Number two, dynamics. And number three, statics. Yeah. So generally, mechanics is broadly classified into three categories, that is kinematics, dynamics, statics. Static means rest. Whenever the study of motion of objects at rest, the study of motion of objects at rest is said to be statics. Under the action of various forces, if it is at rest, if the object is at rest, study of that object is said to be static. And dynamics, it is also the study of motion of objects in motion, study of objects that are in motion by causing the cause of motion, by taking the cause of motion into account, the force. We are going to discuss about the forces that are acting on the objects that are in motion. And coming to the kinematics of our current topic, it also deals with bodies in motion without accounting the cause of motion. A body is thrown, and we are going to study the body motion. That's all. So we least bother about the efforts of thrown, the force with which we thrown, the acceleration we are imparted. So we least bother about that part. Once the body is in the air, otherwise once the body starts its motion, we are going to discuss about its motion parameters. What is the displacement of body, distance traveled by the body, velocity of the body at a given instant of time, or position of body after a certain time interval, etc. We are going to discuss. We are going to deal about bodies in motion without taking into account the cause of motion. So generally it is divided into three parts: kinematics, dynamics, statics. Kinematics means it is the branch of mechanics which deals with the motion of bodies without incorporating the cause of motion, without considering cause of motion. Yeah. So let us see, students. You can see here kinematics. Kinematics, which deals with which is derived from Greek word kinema, meaning the motion, is a branch of physics which deals with the motion of body without taking into account the cause of motion. Yeah. So coming to the dynamics, which is derived from the Greek word dyna, meaning power, is a branch of physics which deals with the motion of bodies by taking account cause of motion, that is force. involvement of force, without involvement of force. This one is with the involvement of force. Statics. Statics means it deals with the bodies at rest under the effect of different forces. Under the effect of different forces, the body remains at rest. It is in static condition, equilibrium, etc. Students, let us take up the definition of point object. What is a point object? So, an object is said to be a point object whose dimensions are negligible when compared to the distances it can cover. Distances it can cover, yes. Let us take up a bus is moving from source to destination by 100 kilometers, let us say. From the starting point, initial point, the destination is 100 kilometer for a bus. Let us say the bus covered 100 kilometers. When compared to the distance it can cover 100 kilometers, the dimensions of bus, they're almost maybe some 10 meters. So it is almost negligible. So we can take it up as a point mass. Yes, car. Let us say a car travel to 200 kilometers on a drive. So when compared to 200 kilometers, the car's dimensions are very small in size. So we can take it up as car is a point mass, point object. So students, you can see an object is said to be a point object if its size is very small when compared to the distance traveled by the body in the given time interval. You can see the example. A bus traveling a distance of 100 km can be considered as a point object. The bus can be considered as a point object. What is the reason? This is because the size of the bus is very small as compared to the distance traveled by it. Let us go for similarly another example. A car is traveling a distance of 50 kilometers can be considered as point object. The reason is the same. That is, this is because the size of car is very small compared to the distance traveled by it. Students, you can see here what is the reference frame. So what is a reference point? So if you want to measure some fixed vectors like displacement of body or position of body or distance traveled by the body, we require some reference point, maybe origin of coordinate system. Origin of coordinate system 0 comma 0 comma 0 can be taken as reference point. Otherwise, I just want to walk for a while. What is my reference point? My house. I started from my house and reached 1 kilometer distance. So what is the reference point to me for my displacement? My house is the reference point. Yeah. So here you can see a fixed point or a fixed object with respect to which the given body changes its position, is called reference point. Maybe I was taken a tree nearby my house is a reference point. A tree is an object which is fixed only. So from the tree I start walking. So that is the reference point. So definitely in physics, reference point is the role of reference point is very vital. So if reference point changes, definitely your displacement will change, distance traveled will change. The meaning of reference point, even reference frames, they are rather very important and useful for better understanding of physics. Means reference point means it can be a fixed point. It can be a fixed point or a fixed object. What is the use by taking this fixed point or fixed object? So that with respect to which can give body changes its position is known as reference point. From the reference point I am at 5 meter distance. After 5 seconds I may be at 7 meter distance. After 10 more seconds I may be at 20 meters distance. So this 5 meters, 10 meters, 20 meters from where I am measuring reference point or fixed object. What it can give? It can give the change in position of me or any object which is in motion. Yeah, students, you can see these are the some examples of rest. What is the meaning of the term rest? A body is said to be at rest if its position is not at all changing with respect to a reference point. Then that body is said to be at rest. Yeah. So there is a chair by the side of you. So it remains at rest. It is not at all changing with time unless until you moved. Maybe through the window you may watch your tree. The tree is by the side of your home if it is. So definitely with respect to you, you are not moving. So you are at rest. You are staring the tree. So it remains at rest, its position will not change with time. There is some electric pole by the side of your home. That electric pole remains at the same location from your house as as time approaches. I mean to say, advancing, as the time advancing. So it is at rest. Even the buildings you can see here. So dear students, this is a tree. So there is a girl who is watching tree continuously. The separation of tree with respect to girl is not changing with time. Then it is said to be at rest. Even an electric pole, a house, you can see. So a body is said to be at rest if it does not change. It does not change its position with respect to time or reference point. Not a big deal. So the objects which remain stationary at a place and do not change their position are said to be rest. Examples: a chair laying in a room is in the state of rest because it does not change its position with respect to the surroundings of the room by itself. Yeah. So these are the some examples for the meaning of rest. So dear students, let us start the topic of motion. So the bodies are said to be in motion if their position continuously changes with time with respect to the reference point or reference frame. So for example, you can take up a car is changing its position with respect to trees because house etc. is in the state of motion. You can see students here, there is a riding on cycle. So their position will change with respect to time with the reference point may be their home. You can see it is a moving car. With respect to the tree sideway, the car is in motion. It is in motion because its position is changing with time. The reference point is maybe sideway trees. Even you can see this part tap of water. Even the water, this particular part of water position is changing with time and he is collecting at somewhere. Even it is changing, its position is changing with respect to the tap, mouth of the tap. So these are the examples for motion, the meaning of motion and examples, the meaning of rest and examples. So students, definitely rest and motion are relative terms. They are related. With respect to the ground, with respect to the earth, we are at rest. If somebody is watching us being from the other planet, we are in motion. So if the reference frame changes, definitely rest and motion are switch over from one to other. Rest and motion are switch over to one to other. So definitely if we take up the tree, the sideway of your home, it is at rest with respect to your house. But if you watch the same tree with the powerful telescope from the other planet, how it appears to be? Definitely it appears to be revolving or moving. It is in motion. The tree is in motion if you see from the other planet. Obviously it is rest and motion are relative and we cannot differentiate them, right, unless until if you specify the reference frame. Students, you can see rest and motion are relative terms because a body can be at rest as well as in motion at the same time. A body can be at rest as well as in motion at same time if the reference frame is changed. Just the example what I explained in the just 2 minutes before. Students, you can see here, when we say that a body or an object is in motion, then it is essential to see whether the body or object changes its position with respect to other bodies or other objects around it, or with respect to any fixed point known as reference point. This is the one. For example, when a bus moves on a road, then the bus as well as the passenger sitting in it changes their position with respect to person standing on the roadside. But with respect to his co-passenger in the bus, his position will not change. That's why again the same passenger is said to be at rest with respect to his co-passenger. But with respect to the person who is on the roadside bus along with the passengers in the bus, their position changes with the time. So they are in motion. So if the reference point changes, definitely term will change. Yeah, you can see. So the bus and the passengers sitting in it are in motion with respect to the person standing on the roadside. However, The passengers sitting in the bus do not change their position with respect to each other. So it means the passengers sitting in the moving bus are not in motion with respect to each other, with respect to co-passengers. So you can understand very nicely by seeing this entire paragraph means, you can see this example. Students, these two are the passengers. He is the observer who is on the roadways, sideways. So with respect to this person who is standing on the roadside, definitely these are in motion, moving bus. These are in motion. These passengers are in motion along with the bus because their position is changing with time. But with respect to this passenger is at rest because always he is by the sideways of him. So that's why here definitely if the reference point changes, if the frame changes, so with respect to this person, all the passengers are in motion. With respect to the co-passenger, or you can see the driver of the bus is the driver of the bus. With respect to this passenger, bus driver is at rest. Because with respect to this reference point or the observer, his position is not changing with time. This position is not changing with time. That's why rest and motion are relative. So here, if we watch the same observer or same object or the body being from the different reference frames, he is attached to ground frame, he is attached to moving frame. The same, you can see if you ask this particular person who is standing on the roadside, what is the state of bus driver? Are bus driver is moving. Bus driver is moving along with the bus, so he is in motion. If you ask the same statement, this particular passenger, any passenger in the same bus, what is the statement they can give? Are he is at rest with respect to me, because his position is not changing with respect to me, because both are all are in same bus. That's why. So that is the meaning of previous paragraph. So example, a person sitting in the compartment of a moving train is in the state of rest with respect to the surroundings of the compartment. So surroundings of compartment means the elements in the compartments. So yet he is in state of motion if he compares himself with surroundings outside the compartment. With the surroundings outside the compartment means like this observer, they are in motion. Yeah. Dear students, you can see here. So in order to describe the motion of an object, we need to keep in mind three things. What are the three things we need to keep in mind? Number one, the distance of the body from the reference point. This reference point is called the origin of motion of the body. From where it was started. Origin. What is the origin of this body? Where this body started? And the direction of motion of body. Okay. Once it is started from the origin, in which direction it is moving? That point also should be in your mind. You should keep in your mind. Second important point. Point number three, the time of motion. For such a motion, what is the time the body was taken? These three are the very useful and important points everybody should keep in your mind as far as body motion is concerned. Point number one, the starting point or the origin where it was started. Number two, in which direction it is moving. Is it moving along east or west, north or south? And number three, you need to be very clear about the time of its motion. Time of journey time. So these three are the very useful and important points, students. Everyone should keep in their mind to study the motion of body. Where it was started, in which direction it is moving, in what time it was reached its destination, etc. Students, you can see the very simple and useful example. So the terms related to kinematics, the distance. So generally in kinematics, we are going to discuss very basic and elementary parameter of object in motion is distance, displacement, velocity, speed, acceleration, and respect to average values. These are the basic parameters everyone should know in the beginning of kinematics. So what is the distance? The distance is obviously whatever the path length traveled by the body in the given time interval is called distance traveled. The actual path length of the body. Actual path length of the body is said to be distance traveled by the body. So the distance traveled by a body is defined as the actual path length covered by a moving body irrespective of the direction in which the body travels. Students, let us say the body starts at A. Let us say body ends. This is the final point. This is initial point or the origin where the particle started, and it is aiming towards east direction. After covering 4 kilometers, again it is turns along north direction. So in this case, what is the distance traveled? Distance traveled means, as its name suggests, distance traveled means actual path length. What is the actual path length? 4 kilometers plus 3 kilometers. 7 kilometers is the distance traveled in this example. Distance, it is a scalar quantity. Yeah. So it is the actual path length. It is the actual path length. Students, here you can see, suppose a man lives at place A as shown in figure 2, and he has to reach another place C, but first he has to meet his friend living at place B. Yeah. Now the man starts from point A and travels a distance of 4 kilometers to reach point B. Students, you can see this is the one. This is A point actually. So here he travels, so north south, indicator diagram, north south east west. Actually person starts at A and he reaches to C point, and he should reach us to C point, but meanwhile there is a point B where his friend is living. Now the man starts from point A and travels 40 kilometers to reach B, to reach 4 kilometers to reach B towards east, and then travels 3 kilometers from B to C towards north. That's the total length. So finally he reaches the destination. What is the total length, students? 4 kilometers plus 3 kilometers, which is 7 kilometers, gives the distance traveled by the body or distance traveled by the man. Yeah. So you can see here, thus the total length of the path, that is AB plus BC, is equal to 4 kilometers plus 3 kilometers. 7 kilometers gives the distance traveled by the man and has no specific direction, because distance is a scalar quantity. As far as displacement is concerned, students, displacement means it is actually the shortest distance between initial point to final point in the direction of final point, because it is a vector. Initial point to final point, the shortest distance between initial point to final point. Whatever the paths you followed, it does not issue as far as displacement is concerned. You can see when a body moves from one position to another position, the shortest distance between the initial and final position. Students, A is the initial position, C is the final position. So actually he walked 4 kilometers east and then 3 kilometers north. But as far as displacement is concerned, it is obviously the shortest distance between initial point to final point, or the straight line distance between initial point to final point, very importantly in the direction of final point, because it is a vector, it is required even direction also. So students, this is displacement. Here it is 5 kilometers is the displacement in this particular journey. Displacement is 5 kilometers. Distance traveled is 7 kilometers. Very importantly, displacement is a vector quantity. In such a case, how to find the displacement of body? And displacement, magnitude of displacement is 5 kilometers. Even I require the direction also. So students, here I am taking the indicator diagram for the sake of clarity. This is north, this is south, and this is east, and this is west. So students, this is 3 kilometers, this is 4 kilometers. So here the angle is 37 degree. Tan theta is 3 by 4. Angle is 37 degree. So direction of displacement is, here it is 37 degree from east towards north. The direction of displacement of body is, its magnitude is 5 kilometer and its direction is 37 degree from east towards north. So it is known as 37 degree north of east. The direction of displacement is, direction of displacement is 37 degree north of east, and magnitude of displacement is, so anyway this is 4 kilometer, this is 3 kilometer, so which is nothing but root over 4 square plus 3 square, which is coming to be 5 kilometers is the displacement. Students, even it is advisable, if you know the unit vector notation, try to represent unit vector wise. You can see here This is east. East can be taken as positive x-axis. East can be taken as positive x-axis. North can be taken as positive y-axis. West can be taken as negative x-axis. South can be taken as negative y-axis. Vertically up can be taken as positive z-axis. Anyway, here the unit vector along positive x-axis is I cap. Unit vector along positive y-axis is j cap. Unit vector along negative x-axis or westward is minus I cap. Unit vector along southward otherwise along negative y direction is minus j cap. So for the same case students, he walks 4 km towards east. Means 4 kilometers towards east means I cap. Then 3 kilometers towards north. That is 3 units, and northward this is the displacement, or we call it as this is AC bar. This is the vector, displacement vector, 4I cap plus 3j cap, from which you can easily find out magnitude of vector as well as direction of vector.
Add-on solutions. Add-on desires.